welcome to our innovation talk, partnering for AI ready infrastructure. And I'm super excited to introduce our esteemed speaker for today, Mr. Venkat Raman Swaminathan, VP Secure Power, Greater India Zone. Without further ado, I will give stage to you, sir. Thank you.
Thank you very much. Warm welcome. Good afternoon. Really appreciate your presence here. You know, I would have, if it would have been an open forum, I would have said, what is AI? Okay? So we are hearing a lot about AI, right? So, you know, I want to simply define, when a human talks to human, it is human intelligence. Okay? When a human talks to a computer and the computer is intelligent enough to answer some of the questions, so because the computer is created artificial, so that's why we call it artificial intelligence. Now, maybe it evolves that the computer starts talking to a computer and still things are happening. Okay? So we don't want that to happen. Humans have to exist. So we'll remain with artificial intelligence, and just let's look at what's the impact of artificial intelligence in the world. And you know, I'm telling you what I'm going to be ending the session with. This is going to be complicated, and that's why the title is Partnering for AI Data Centers. Till now, customers knew what they wanted to buy. You know, some of us are partners in this forum. Customer sends out a BOQ. They exactly know they need to buy a UPS, they need to buy switchgear, they need to buy cooling. All that is generally known because the cloud data center has been in that way. But when it comes to artificial intelligence, the customer actually does not know what he wants or what they want. And that's why we are saying that we have to partner, because it's not going to be easy. Let's go through with it very quickly. Now, again, I would have asked a question typically. It took only 2 or 5 hours for ChatGPT to get 1 million subscribers. Whereas if you look at Netflix, to get 1 million subscribers, they took almost 2.5 to 3 years. And you can imagine what it is creating. Okay? Now, potentially, if you have a co-pilot in your laptop, and if you want to say that, please give me a presentation which I want to present to my customers about Schneider Electric's sustainability capability, you know what? Exactly 2 minutes and 1 second, it will give you a 35-slide PowerPoint presentation which is absolutely relevant. That's the power of AI, which you would have taken 2 to 3 days to prepare if you want the same thing. And that's ChatGPT for you, and that's your co-pilot, what it can create. So, and therefore, the pace of digital adoption is amazingly high. Can we stop it? The answer is no. Because smartphone adoption has taken, and now with the smartphones, the AI adoption is going really berserk. So you can see, now for doing this, the raw material for data is power, energy. Okay? And therefore, we are correlating the AI evolution or the AI explosion to the power production. So that's where the whole thing is. In Schneider parlance, we used to call it energy dilemma, because your energy guzzlers, the industrialization, the digitization is picking up energy in a massive way, and you're supposed to drop the carbon footprint because the earth cannot be heated more than 1.5 degrees. So 2100, if it continues to be this way, we're going to be non-existent because the oceans are going to come into the... So if that's going to be the sustainability pitch for all of us, we need to be careful on what we are doing with the energy despite AI. And I will be covering some of this in this presentation. Digital economy worldwide, not only in India, is impossible without data. And that's where I'm saying that the internet users are going up. The industry is going for IoT devices. 61% yearly big data growth, amazing again. And then 16 terabytes, 16, that's the investment which is happening in AI. Back home in India, I'm not sure if you are aware, Center for Development and Advanced Computing, CDAC, is Rudra is going to be a India for India GPU. So, and the pilot project is already happening in Bangalore. So maybe India is going to grow into AI by self-creating, make in India type of servers, of course with some help from various places. So, but it's real. Of course, NVIDIA and AMD are going to be bringing in and more faster chips. So data is going to be, we say that data is the next oil. Now, industrial revolution. One of the applications is going to be on the industry side where there again it's going to be a huge amount of, you can see the numbers there, I don't want to read it out for you. 100 million chat in first 2 months, as I said, they had, now we are all about DeepSeek. You can ask me questions on that, it's still not defined clearly, but that's where it is. And look at the 60 billion in terms of YTD investment in AI. I'm not sure if you're aware, in India there are already 3 service providers who can provide you GPU as a service. Okay? So that's where it is going on. So I want to let you know that there is development and deployment. You can see those parameters, cloud and data center, self-driving cars. Yes, in Singapore might be faster, but in India it's going to be still later. Intelligent machines and generative AI in that sense. Let me give you a point here. Our Prime Minister went to the AI conference in France and he found out some anomalies of, I'm not sure if you followed that article. He says that, because the computer knows that most of us are right-handed, it is even not able to, it says that, Obama is a right-hander. Actually, Obama is a left-hander. So there is still development which needs to be happening there. Now I'm bringing it home into India. We have 25, 26 official languages with scripts. And we have maybe 1,200 to 1,300 dialects in the country. Okay? So the same word has different meanings in various languages in our country. Understand this. Kundi is a bad word in south of India. Kundi is a safety word in north of India. And imagine you're going to be doing an AI search for that. There's a clash of interests here. So again, India is unique. Like Make in India, we have to have AI for India. And then the farmer in north versus farmer in south, he clicks, he gets various output. So what I'm trying to say is, that aspect of getting the computer, I told you artificial intelligence is all about human relating with a computer. Now the computer has to learn what is Telugu, what is Tamil, what is Malayalam in that context. So that is part of the development, the training part of it. This means huge investment of database. This means the computer has to be trained. What I roughly know is there are 35 billion characters in the ecosystem. In a sense, various languages, etc., put together. All that has to be, the computer has to get trained to do that, and then the inferences will come. That's the deployment part. That is where the use cases are coming up. Okay? That is where, you'll be actually able to utilize the AI, and that's something which I wanted to. So this means huge processing of data once again. Okay? Now, AI deployment brings its own challenges into the data center market. One is the capacity. Okay, now most of the data center players, they're running out of capacity. They want additional, land parcels, additional power. So that related to the need of power, it's almost no space availability. Okay, we visited a data center last week, 8 megawatt full, 30 megawatt full. So that's where it is. Rental rates are going up, and design. There is an update of design in all the hyperscalers, for instance. Now, Schneider's analysis is You can see on the left-hand side, 2025, we have around 13%. It's not that India does not have. We already have Indian Institute of Tropical Meteorology. You have the Indian Meteorological Department. We are doing, tsunami predictions and all that. All that is all mathematical models. It's all based on AI. Now, it's already there. Liquid cooling is already being done by these companies, CDAC, IITM, etc. So 2025, our estimation is 13% would be on that AI framework, and 2030 it's expected to be 36%. And 36%, but the data size is so massive, it's going to be phenomenal. And then, therefore, you can see that the predictions are all going wrong. The power requirements are going to be phenomenally high as far as AI is concerned. Now, to thrive in the new AI era, data centers need to be optimized on power. I told you about the energy dilemma. We want more and more data for everything, but when you need that data, it has to be processed, which means power is the electrical energy is the input, but we have to consume less of it if the planet has to be sustainable. So that's the problem we have. So deploy high energy infrastructure, but you have to be sustainable. This is going to be the pressure on all the hyperscalers as well as the co-location providers. Now, energy strategy for the AI data. One is, the good thing about Schneider Electric is when we say that we want to be sustainable, we start from the energy procurement. All of you know that diesel generator sets, we would like to do away with it because it's a carbon, it's an energy guzzler, which means fossil fuels are going to be used, CO2 emissions are going to be very high. So people are trying to move to battery energy storage systems. Why? Because you can store solar and wind energy into the lithium-ion batteries and use it as substitutes. So that is getting popular. Hydrogen fuel is getting popular. Fuel cell. In fact, our management team visited one of the data centers where in India fuel cell has been implemented as well. So energy procurement strategy has to change now with the guzzling of power. On-site power generation has to be thought out. I spoke about it. Battery and backup resources and manage the power resources. So power is going to be scarce and we have to be careful. So primary power, backup power will be the available power, but we need to make it sustainable, and that's where we are, the challenges are strategic sourcing of energy and various. So Schneider can provide you solutions for this. I'm not going to elaborate about this, but my request is that, we have to be, that's why we started off saying that we have to partner for the AI evolution or revolution, and that's where Schneider has a very important place. So we would like to partner here. So welcome to the new era of data centers. We call it grid to chip and chip to chiller. Okay? What's so special? Because the rapid compute evolutions, okay, the ultra power density, race to the AI leadership, everybody wants to come into AI. So what's happening is, can the conventional data centers which have been traditionally on air cooling, can we adapt it to liquid cooling? This is one of the questions our customers are asking. Number two, I want to build a data center. My power capacity is 30 megawatt, but my customer is not sure whether it will all be liquid cooling. You saw the number. It is now 36% is what we are expecting. So if I build a 100 megawatt data center, should I provide for 36 megawatts of liquid cooling? Will I be done? And the balance in terms of the conventional cooling. Now, how do you have that complex structure within the building? Should you do it pod-wise? So these are the major dilemma which is coming in. So the dynamic power profiling and the architecture variability. Why do I say architecture variability? Contrary to the, let me give you something about the cloud data center to tell you how it moves. The cloud data center, the data center is initially loaded to 15 to 20%. Then it goes to 50%, then it goes to 80%. Customer says, my data center is full. At 80% load, the UPS is absolutely steady. The cooling achieves a steady state. It's cooling and under raised floor cooling or whatever it is, it's beautifully done. But what's happening in AI is the GPU is 1 megawatt, goes up to 15 megawatt, comes down to half megawatt, goes up to 20 megawatt, and goes down to 15 megawatt, 0 megawatt, goes up to 15 megawatt. So this happens not in hours, but in minutes or sometimes seconds. So because of the training, inference may be still better, but in the training stage, the processing is so high. And as a result, you need, let me give you the situation. If you are aware of how a UPS behaves, so the UPS out is connected to the load output. So the UPS is getting a signal, the load is 1 megawatt. The UPS brain says, oh, okay, 1 plus minus 10% is fine, 1 plus minus 15% is fine. But 15x difference, the UPS says, oh my God, I made a mistake. Now I drop the load and put it to battery. Now imagine if the load is going on to battery every 15 minutes for multiple times. You have definitive 1,000 cycles or 10,000 cycles in a lithium-ion battery. Now your battery is going to be dead in 2-3 months. Again, you have an issue. That's where I'm talking about the architecture variability. Now imagine the cooling design for this when you are having this type of a load. Therefore, we say the UPSs have to be, AI workload tolerant. So when this load is fluctuating, your firmware says, oh, okay, now you don't have a cloud load, you have an AI load, buddy, you're good. You don't need to put it on the battery. So this is where Schneider is evolving our firmwares to suit the various types of, and AI load while training, AI load versus inference, again there is a difference. So you need to know how the load profile is, and then the UPSs have to be done. So even if it is during inference, in an industrial situation, again the load profile is changing. Now, Indian regulation calls for transformers, oil-filled transformers cannot be inside the building. So now dry type transformers are coming into the building, and as a result, our power management modules will not have a transformer. Therefore, the MCBs and the circuit breakers, the KA rating is changing. So you can imagine that the load profile is actually changing the entire upstream or downstream electrical designs. And therefore, as I said, we need to partner. Our panel builders have to know this. Our IT partners have to know this when they are putting together the whole design. So if that's clear to all of you, let's go into the next step, where it all starts with the GPU. CPU, Central Processing Unit, it's just a processor. You've seen Intel, AMD, all those processors. GPU is the graphic processing unit. Okay, this is the stroke of luck. All the gaming computers were manufactured by NVIDIA. They struck luck, saying that now the gaming profiles can be brought into data processing, and that's how the whole industry is talking about. Now, I'm not going to define to you the B100, and there's so much of evolution. And we already know it started off with a few watts per chip. Now it's almost 1 kilowatt per chip, the latest one, which is going to be launched in 2025. Now imagine the mechanical cooling person's nightmare. Okay, so it's going so high. Now, again, let me give you, the chip is going to be, say, around 60 to 80 degrees centigrade. If you touch the chip, you're going to get, obviously. So it goes onto a cold plate, and then you put in water or liquid into the cold plate, and then the cold plate is going to dissipate the heat. Now, all this is 60, 80 degrees centigrade, right? So now, what is the water temperature or the coolant temperature which you require to cool? Now, this is where the engineering is getting very, very complicated, and that's what has created in the advent of the GPU. Now, let's talk about the grid to chip. I see a lot of our electrical fraternity here. You will be very, very keen. The switch gear, it will go through a bit of change. We are not going to fundamentally change the product. As I said, our PMMs, instead of 10 kiloampere rating, the MCB, it has to go to 15 kiloampere rating because the transformers are being removed. Because why the bigger transformers are moving, you can't have that much of losses because the megawatts of power, every small loss in the transmission, you're going to have a problem. It is going to be a huge, so that's where we are talking about the switchgear changing. Then the second one is the UPSs have to become highly efficient. Okay, so if you have a chance to go to the booth there, we have what is called GVXL, where AI is demanding for better footprint. So in 1.25 megawatts in 1.2 meters footprint, world's best. You can validate it with all our friends in the market. This is the smallest footprint because you need to install more UPSs to power the whole thing. Next comes the high power final distribution. Gone are those days where you'll have 3 kilowatt per rack or 5 kilowatt per rack. Now, Schneider has a validated data center which can go up to 42 kilowatts per rack. And now the latest is, with the latest 2025 launched chips, staggering 125 kilowatt per rack. Okay, so if that has to be powered and cooled, the busways and all that has to change. It has to become more reliable. You can't have cables doing this job. In fact, for you, why it is becoming so compact is because the GPU, when it's talking from, we used to have a battery of rack. I see Syed here, you have to have a battery of rack, right? So now the GPU does not have the time to communicate from one rack to the other rack. So they want all the GPUs in one rack. That's why the power density is going within the rack. And at best, you can have the optical fiber cable in the next rack. It has to communicate. Latency cannot be, because let me give you, I told you that only Singapore can have driverless car. Now the driverless cars, every minute, it throws out terabytes of information. So next is the edge. AI on edge is going to be increasing in the country as well as the AI applications go up. So Singapore, for instance, is a small country city. They will have to have AI on the edge because there are cars moving, driverless cars moving. It's throwing terabytes of data, and it has to. You have to say that, oh, navigate this way, navigate. All that has to be automated. So that's where I'm saying that the high power final distribution. Why Schneider is in Elecrama talking about AI is the electrical infrastructure is going to go through a disruption. We have to be ready. We have to partner with each other, so that the Schneider, R&D is feeding in all this information. And of course, the last mile, the rack and containment, it's not going to be normal, it is changing again. Now, the next one is the chip to the chiller. Okay? Remember, I told you, the chip is going to be 60 to 80 degrees centigrade. Okay? Imagine your whatever tool at home, you put it in the gas, and you just drop it in water, right? That's the impact it is going to create. Now to do that, why do you require, normal chillers are 18 degrees, 20 degrees temperature, which is cold, right? Relatively cold in Indian context. So, but why do you require that temperature? You can increase the chilled water temperature to something like 26, 27, 28. So that's where you see the third item, high temperature chillers. Okay? Conventional chillers, if for this, you see the air conditioning ducts here, this chiller would be 7 degree outlet and 12 degree inlet. And now cloud data centers are almost 20 degree outlet and 28 degree inlet. Now we are talking about 28 degree outlet and something like 40 degree inlet. Okay, so that's about the high temperature. Then liquid to liquid, CDU means coolant distribution unit. As I said that the servers cannot be cooled by air anymore because of the heat density. You have to use liquid or water or fluid. So that's why that is, and the technology cooling loops are coming in. Technology cooling loop is the one within the data center, and then high temperature chillers, air cooling and chillers. So you saw the distribution is 36% liquid cooling and the rest is still air cooled servers. So air cooling will continue, but again that has to become more efficient. It can be using chilled water, but it has to become more efficient, is what we are saying. So all this, we have a team, Schneider has a team which is working with NVIDIA as we speak. All their evolutions have to be understood. They also have to see how the equipment manufacturer can cater to it. Okay? So the chip manufacturer, the server manufacturer, the tech aggregator, and the hyperscalers, it is a community. Gone are these days. See, it's like this, right? When, we have UPS competition, cooling competition, various switchgear competition. I can tell you one thing is going to unite all of us. The benefit of the planet. When our third generation, fourth generation are at, real risk of surviving in this planet, we cannot be competing. We have to be together in terms of the sustainability. So if that be the case, we have to partner in the AI era, we have to partner with each other to do this. So align the sustainable strategies with business growth, drive the power and water efficiencies, decarbonize supply chains. This is where Schneider is an expert as well. Priorities the low embodied carbon and compliant sustainability reporting. Sustainability not for your balance sheet, but sustainability to be on the ground. Okay? So how do we decouple the AI data center growth from energy consumption? And that's where I'm saying that, scope 3 emissions. This is all about Schneider sustainability. We are, last 15 years, we have been doing this. We are experts in this. Again, I would request our partner ecosystem as well as customer ecosystem to contact us. Venkat Garimala is the expert in this. We can do this. New regulatory requirements are coming in. Rebuild your sustainability strategy in line with what is the AI which is coming up. So there are a lot of players who want to set up data centers. But if they don't have a sustainability strategy, believe me, not many people will even acquire them. Because in future, AWS, Microsoft, Google, Meta, everybody will be told, build a sustainable, profile when you're doing it. Now I want to talk about the Indian context where Infosys, Accenture, Capgemini, they will all be creating the applications for the end use of the data. They have to be also sustainable because they will be hosting the AI, the edge data centers as well. One of the data center operators is already talking about 125 edge data centers. So like this, for your information, Nepal, the largest colo provider, has already given us order for 15 edge sites within Nepal. Can you imagine this? So where free cooling is also possible. So I'm saying that the deployment of the sustainability strategy is going to be very, very key. So our business is to make your business and your operation more sustainable. And the enables of sustainability is the power, which we talked about, people, because we have to educate and empower our people, and it's all about the partnership. Okay? Now that's my last slide. There are a lot of white papers. It's all in public. You don't need to be worried about anything. White paper, the AI disruption challenges guidance for data centers, which is 110. You can have the revolutionizing the decarbonization strategies in 106, sustainability metrics for data centers in white paper 67, and then all the reference designs are also available. Please go through them. Very, very informative, and it is path breaking in terms of how do we, and Schneider is going to be updating the whole industry. So here, do we feel that we are educating the market and educating our competition? We want to do that, because sustainability is going to be the ultimate in the AI revolution. With that, thank you very much. If there are any questions, we can take it.